Right now, as you are watching this video, you are moving through space. It may feel like you are completely still, but the reality is very different. You are standing on a planet that is spinning thousands of kilometers per hour. Earth is traveling around the Sun at incredible speed. The Sun itself is moving around the center of the Milky Way galaxy, carrying our entire solar system with it. But the story does not end there. The Milky Way galaxy, containing hundreds of billions of stars, is also moving through the universe. And the most mysterious part? Our galaxy is not just moving randomly. It appears to be traveling towards something massive, something invisible, something powerful enough to influence the motion of thousands of galaxies. Scientists call it the Great Attractor, a mysterious region of space that has confused astronomers for decades. But what exactly is pulling our galaxy? To understand this mystery, we first need to understand one simple fact. Nothing in the universe is truly standing still. Everything is moving. Earth rotates on its axis. Earth orbits the Sun. The Sun travels around the Milky Way. And the Milky Way itself is moving through the enormous cosmic ocean of space. For a long time, scientists believed that galaxy movements were mainly caused by the expansion of the universe after the Big Bang. But when astronomers started studying galaxy motions more carefully, they noticed something strange. Many galaxies were moving slightly differently than expected. They were not only moving because space itself was expanding. They seemed to be drifting toward the same direction. It was almost like an invisible river was carrying entire galaxies through space. But what could create such a powerful gravitational pull? The answer came from studying one of the oldest signals in the universe, the cosmic microwave background, also known as CMB. This ancient radiation was created shortly after the birth of the universe, around 13.8 billion years ago. Scientists expected this radiation to look almost identical in every direction, but they found something surprising. One direction appeared slightly warmer, while the opposite direction appeared slightly cooler. This tiny difference revealed something huge. Our galaxy was moving. Scientists called this effect the CMB dipole. It showed that the Milky Way and nearby galaxies were traveling through space at an enormous speed. But this discovery created an even bigger question. Where are we moving toward? In the 1980s, astronomers began mapping the movement of thousands of galaxies. They studied their distances and speeds to understand how they were traveling through the universe. A group of 7 astronomers, later known as the 7 Samurai, investigated this mysterious motion. Their research revealed something shocking. Thousands of galaxies appeared to be flowing toward one particular region of space, a region that contained an enormous amount of hidden mass. They gave this mysterious gravitational influence a name: the Great Attractor. But the mystery was only beginning. Because if something this massive exists, why can't we simply see it? The answer lies behind a hidden region of our own galaxy, a place where billions of stars, dust, and gas block our view. And this is where the search for the Great Attractor becomes even more fascinating. The hidden side of the universe. The biggest mystery about the Great Attractor is not only its enormous gravitational power. It is the fact that we cannot easily see it. The Great Attractor is located in a direction where our own Milky Way galaxy gets in the way. Our galaxy is not just a collection of stars. It is a huge disk filled with billions of stars, clouds of gas, and massive amounts of cosmic dust. When astronomers look toward the Great Attractor, they are looking through one of the most crowded regions of our galaxy. Scientists call this area the Zone of Avoidance. It is like trying to see a distant mountain through a thick fog. The mountain may be there, but the view is blocked. For many years, this made the Great Attractor one of the biggest mysteries in astronomy. Visible light telescopes could not clearly observe what was hiding there. But as technology improved, scientists started using different types of telescopes. Infrared and X-ray telescopes allowed astronomers to see through some of the dust and gas blocking their view. And what they discovered was incredible. Hidden behind the dust was a massive concentration of galaxies. A giant galaxy cluster known as the Norma Cluster. This cluster was located almost exactly where scientists expected the gravitational pull of the Great Attractor to be coming from. For a moment, it seemed like the mystery had been solved. But then scientists discovered another problem. The Norma Cluster was huge, but it was not massive enough. Its gravity alone could not explain the movement of all the galaxies around us. Something even larger had to be involved. Astronomers continued looking deeper into space, and they found another enormous structure. Far beyond the Great Attractor, around hundreds of millions of light years away, exists the Shapley Supercluster. It is one of the largest concentrations of galaxies ever discovered. A supercluster is not just one galaxy. It is a giant collection of galaxy clusters connected by gravity. The Shapley Supercluster contains thousands of galaxies and represents one of the most massive structures in our nearby universe. This changed the way scientists viewed the Great Attractor. Maybe it was not the final destination. Maybe it was only one part of a much bigger cosmic system. Imagine standing on a river. The water near you may be flowing toward a small stream, but that stream is connected to a larger river, and that river eventually flows toward an even bigger ocean. The same idea may apply to galaxies. The Great Attractor could be a smaller gravitational valley inside a much larger cosmic landscape. A place where galaxies are slowly flowing because of the combined gravity of enormous structures. But then another mystery appeared. In 2008, some researchers studying galaxy movements noticed something unusual. Some distant galaxy clusters seemed to be moving in a coordinated direction that could not be fully explained by known structures. They called this strange idea dark flow. The possibility was fascinating. Could there be something even larger pulling on our universe? Could there be massive structures beyond what we can observe? Some scientists suggested that dark flow might be evidence of extremely distant matter affecting our region of space. Others argued that the data was not strong enough, and that the effect might disappear with better measurements. The debate continues. But whether dark flow is real or not, it reminds us of something important. The universe is much more mysterious than it appears, and the Great Attractor may only be one piece of a much bigger cosmic puzzle. Because when scientists zoomed out even further, they discovered that our galaxy is part of something much larger than anyone imagined. A giant structure called Laniakea. For a long time, scientists thought galaxies were scattered randomly throughout the universe. But when astronomers created more detailed maps of cosmic structures, they discovered something extraordinary. Galaxies are not spread out randomly. They form enormous patterns across space, huge chains of galaxies, massive clusters, and giant empty regions called voids. Together, these structures create something scientists call the cosmic web, and hidden inside this cosmic web is our own galactic neighborhood. In 2014, astronomers made a groundbreaking discovery. They realized that the Milky Way, the Great Attractor, the Norma Cluster, and thousands of other galaxies are all part of one enormous supercluster. They named it Laniakea. The name comes from the Hawaiian language and means immense heaven. And the name fits perfectly. Laniakea is not just a group of a few galaxies. It stretches across around 500 million light-years of space. It contains thousands of galaxies. And its total mass is estimated to be equal to around 100,000 Milky Way galaxies. Think about that. Our entire galaxy, with all its stars and planets, is only one tiny part of this enormous cosmic structure. At the center of this massive region is the Great Attractor. But it is important to understand something. The Great Attractor is not like a giant vacuum cleaner pulling everything toward it. It is not going to suddenly drag Earth into space. The distances involved are unbelievably large. Gravity works across enormous scales, but these movements happen over millions and billions of years. The universe moves slowly. Very slowly. The Great Attractor is simply showing us how gravity shapes the largest structures in existence. Every galaxy pulls on other galaxies. Every cluster influences nearby clusters. Over billions of years, gravity creates the incredible patterns we see across the universe. But there is another mystery hidden inside this story: dark matter. Scientists believe that a large amount of the mass influencing galaxies is not made of normal matter. Normal matter is everything we can see: stars, planets, gas, dust, everything made of atoms. But dark matter is different. It does not produce light. It does not reflect light, and we cannot directly see it. However, scientists can detect its presence because of its gravitational effects. Galaxies rotate in ways that suggest there is much more mass present than what we can observe. The same idea applies to giant cosmic structures like Laniakea and the Great Attractor. A large part of their gravitational influence may come from invisible dark matter. This means that when we look at the universe, we are only seeing a small part of the complete picture. Most of the cosmic story is hidden, and that is what makes the Great Attractor so fascinating. We can measure its effects. We can calculate the movement of galaxies. We can estimate its mass, but we still cannot see the entire structure clearly. Even today, advanced telescopes are trying to uncover more secrets about this mysterious region. Future missions using infrared technology, X-ray observations, and powerful galaxy surveys may reveal exactly what lies behind the dust of our own galaxy. Because every time we think we understand the universe, it shows us something even more surprising. The Great Attractor is not a monster waiting to destroy us. It is not a black hole swallowing galaxies. It is a reminder of something much bigger. A reminder that our planet is part of a galaxy. Our galaxy is part of a supercluster. And that supercluster is part of a universe so enormous that human imagination struggles to understand it. But the story of the Great Attractor does not end here. Because the deeper we explore the cosmos, the more mysteries we discover. The universe is filled with things we can see. Stars shining across millions of light years. Colorful nebulae creating new worlds. Galaxies containing billions of suns. But the strange truth is, the universe is also controlled by things we cannot see. The Great Attractor is one of the best examples of this. Scientists discovered it not because they saw it directly, but because they saw its effects. They watched galaxies moving. They measured their speeds. They calculated the gravitational forces acting on them. And they realized that something massive was influencing their journey through space. This is how modern astronomy often works. Sometimes the universe reveals its secrets indirectly. A black hole is discovered because of the way nearby stars move. Dark matter is discovered because of the way galaxies rotate. And the Great Attractor was discovered because entire groups of galaxies were moving toward an invisible gravitational region. But what exactly creates this powerful pull? The answer is not one single object. It is a combination of enormous structures spread across unimaginable distances. Galaxies, galaxy clusters, gas, and possibly huge amounts of dark matter. Together, they create a gravitational landscape that shapes the movement of galaxies across the universe. Imagine placing a heavy ball on a stretched fabric. The fabric bends around the ball, creating a slope. If you place smaller objects nearby, they will naturally move toward the lower area. Gravity works in a similar way. Mass changes the shape of space itself. The larger the amount of mass, the stronger the effect. The Great Attractor represents one of these massive gravitational valleys in the universe. But there is another important question. If gravity is pulling everything together, why isn't the entire universe collapsing? The answer is because the universe is a balance between different forces. Gravity pulls matter together, but the expansion of the universe pushes space outward. After the Big Bang, the universe began expanding. Over billions of years, galaxies formed, clusters developed, and giant structures appeared. Gravity created the cosmic web. Expansion continues to stretch it. This constant competition shapes the universe we see today. The Great Attractor exists inside this enormous battle between gravity and cosmic expansion. It is a place where gravity has gathered huge amounts of matter together. But even the Great Attractor is not the largest structure we know. Beyond it are even bigger cosmic formations. massive superclusters connected across hundreds of millions of light years. These discoveries changed the way humans see our place in the universe. For centuries, people believed Earth was the center of everything. Then we discovered our planet orbits the Sun. Later, we learned our Sun is just one star among billions inside the Milky Way. Then we discovered that the Milky Way is only one galaxy among trillions. And now we know our galaxy is just a small part of an enormous cosmic network. The Great Attractor is another reminder that we are not separate from the universe. We are moving with it. Our galaxy is traveling through a cosmic ocean, surrounded by invisible forces that have been shaping its journey for billions of years. But even with all our technology, there are still limits to what we can discover. Some regions of space remain hidden because of distance. Others remain hidden because of obstacles inside our own galaxy. And some mysteries may require completely new technology before we can understand them. The Great Attractor teaches us an important lesson. The universe is not only about what we can see. Sometimes the most powerful things are the things we cannot see directly. The invisible forces, the hidden structures, the unknown regions waiting to be explored. And the more we look deeper into space, the more we realize how much remains undiscovered, because the universe is not just bigger than we imagined, it is stranger than we imagined. Even after decades of research, the Great Attractor remains one of the most fascinating mysteries in modern astronomy. We have learned a lot about it. We know that something massive is influencing the movement of galaxies. We know our Milky Way is part of a much larger cosmic structure. We know gravity is shaping the movement of galaxies across enormous distances, but many questions still remain unanswered. How much mass is really hidden there? How much of that mass comes from visible galaxies? And how much comes from the mysterious dark matter that we still cannot directly detect? These questions show us how much we still have to learn about the universe. One of the biggest challenges is that humans are observing the cosmos from inside it. We are not looking at the universe from the outside. We are inside our own galaxy, surrounded by billions of stars and clouds of dust. It is like trying to understand the shape of a giant forest while standing between the trees. You can see parts of it, but understanding the entire picture is much harder. This is why studying the Great Attractor has required some of the most advanced technology ever created. Normal telescopes that observe visible light struggle to see through the dense dust of the Milky Way, but infrared telescopes can detect heat and radiation passing through some of those clouds. X-ray telescopes can reveal extremely hot gas surrounding galaxy clusters. And new sky surveys are helping scientists create more detailed maps of the universe than ever before. Every new observation gives us another piece of the puzzle. But sometimes, discoveries create even more questions. The Great Attractor is a perfect example. When scientists first found evidence of this mysterious pull, they believed they had discovered the source of our galaxy's motion. But later observations showed that the story was much bigger. The Great Attractor was not the end of the mystery. It was the beginning. Behind it were larger structures. Beyond those structures were even greater concentrations of galaxies. The universe kept revealing more layers, almost like opening a series of doors, only to discover another mystery waiting behind each one. And this is what makes astronomy so exciting. Every answer creates new questions. When humans first looked at the night sky, we saw only points of light. Today, we understand that those tiny points are entire galaxies containing billions of stars. We have discovered planets around other stars. We have detected gravitational waves. We have photographed the shadow of a black hole. And yet, there are still enormous parts of the universe that remain unknown. The Great Attractor represents that unknown. It reminds us that even in an age of advanced science, the universe still has secrets. But perhaps the most amazing part is not the mystery itself. It is the fact that we are able to ask these questions. A small species on a small planet has developed technology powerful enough to study structures hundreds of millions of light years away. We can measure the movement of galaxies. We can study radiation that has traveled for billions of years. We can explore the history of the universe itself. And all of this started with humans simply looking up at the stars and wondering, what is out there? The Great Attractor is not a threat. It is not something that will suddenly destroy Earth. The distances are far too enormous, and cosmic movements happen over unimaginable periods of time. Instead, it is a cosmic reminder. A reminder that we are part of something much larger than ourselves. Our planet is part of a solar system. Our solar system is part of the Milky Way. The Milky Way is part of Laniakea, and Laniakea is just one tiny region inside a universe filled with billions of galaxies. The story of the Great Attractor shows us one of the most beautiful truths about science. The more we discover, the more we realize how much there is still left to explore. The Great Attractor is one of the greatest examples of how mysterious our universe truly is. A force that we cannot see directly, a region that we cannot fully photograph, and a structure so enormous that it influences the movement of entire galaxies. For thousands of years, humans looked at the night sky and believed the stars were just tiny lights placed above us. But modern astronomy has completely changed that idea. The universe is not a simple collection of stars. It is a giant, connected structure where galaxies move, interact, and influence each other through the invisible force of gravity. The Great Attractor is part of that story. It shows us that even our enormous Milky Way galaxy is not traveling alone. We are part of a much larger cosmic journey. Every star in our galaxy, every planet, and every person on Earth is moving through a universe that is constantly changing. And the most fascinating part is that we are still discovering how it all works. Scientists continue to study the Great Attractor using new technologies. Future telescopes and advanced mapping systems may reveal more details about this hidden region of space. They may help us understand exactly how much mass is there, how dark matter is distributed, and how these gigantic cosmic structures formed over billions of years. But even if we eventually solve the mystery of the Great Attractor, the universe will still have countless secrets waiting for us. Because every discovery opens the door to new questions. There are galaxies we have never seen, planets we have never explored, and regions of space that may contain phenomena beyond our current understanding. The Great Attractor teaches us something important. Sometimes the greatest discoveries are not about finding something we can easily see. Sometimes they are about finding something hidden through the clues it leaves behind. A movement, a pattern, a gravitational effect, a signal traveling across the universe. From the smallest particles to the largest galaxy clusters, the same laws of physics connect everything. The same gravity that makes an apple fall on Earth also shapes the movement of galaxies across hundreds of millions of light years. And that is what makes the Great Attractor so incredible. It is not just a mysterious place in space. It is evidence of the powerful forces that have been shaping the universe since its beginning. So the next time you look at the night sky, remember this: you are not standing still. You are traveling on a planet moving through space. That planet is circling a star. That star is traveling through a galaxy. And that galaxy is moving through one of the largest cosmic structures we have ever discovered. Somewhere in the darkness, the Great Attractor continues to influence this incredible journey. A hidden giant, a cosmic mystery, and a reminder that the universe is far bigger, stranger, and more amazing than we could ever imagine. If this journey through the cosmos amazed you, make sure to like this video and subscribe to the channel for more incredible discoveries about space, galaxies, black holes, and the biggest mysteries of the universe. Tell us in the comments, what cosmic mystery should we explore next? Because the universe still has countless secrets waiting to be uncovered. Thanks for watching, and I'll see you in the next journey beyond the stars.